Hello, so today I'm going to be going over homework 9 for the class EEDG 6370 offered in the fall of 2024 at UT Dallas. And so to start off, we're just going to look at Cordis and look at what we were supposed to implement. So if we go over to the IP components and then we launch this QSys thing in the platform designer. So now that we have this up, we can see that what we're supposed to implement is this PIO LED, and we connect the clock to, you can see right here, it's connected to clock 0. The reset is connected to the clock 0 reset. S1 is connected to the HPS 0 H2F underscore LW underscore AXIMaster. And then the external connection goes through a conduit, and it is connected to the LEDs on the board. And so then you generate the HDL for this. And over here you can see that we set the width to 10, we set the output to, or we set the direction to output, and we set the reset value to 3FF. And then if you hit this generate button, you can go and look at the instantiation template. And in this template, you can see that we're supposed to connect to this PIO LED port. Now back over in Cordis, you can look at the files, and we can look at the top, and you can see the instance in here. We have the SoC system instance, and we connect the LEDs to the LEDR port. And from here, you have to compile down to the analysis and synthesis. And then what you do is you go to tools and you go to tickle scripts, and then you run the P0 parameters and P0 pin assignments. And then once you run those two tickle scripts, you can do the rest of the synthesis. And since you have to do all of this over in the Linux environment, then you'll have to copy over the SOF file to your Windows environment. And then the next part all happens in the Windows environment. So what you're going to have to do is you're going to have to open the command shell. And then in the command shell, you're going to have to navigate your way over to the FPGA folder. And in this FPGA folder, you have to run the script to generate the header file. And that's right here. It'll generate this HPS underscore 0.h file. And then you take that over to the Linux, or to the HPS folder, HPS-C folder. And then in that, you just run the make. And then once you run this make file, you'll actually copy this over to the system. So how I did this was I used the scp command. So I had to run this scp command where I did my first HPS FPGA to the root at the IP address for the FPGA, and then I copied that over. And then over in Cordis on the Windows platform, so I hit auto detect, and then I added the file, the SOF file that I had generated over on the Linux version of Cordis. And then I ran this. What happens at this point is for me at least, I could no longer see the screen on the FPGA. But when I type in / my first HPS hyphen FPGA, then it will run through, it'll cycle through the LEDs on the FPGA, and now I will cut to a video of that. Okay, so now I have my FPGA set up over here. It has been programmed, and before I ran this already, so hopefully I can just hit up and then enter, but we'll see if that works. So it did, and you can see that it is cycling through all the different LEDs, forward and backward. I'll do that for a while. The one downside I see right now is I don't have the screen working. I don't know if that's intentional or not, but anyways, the design is in fact working. Okay, so what I did just now for part 2 is I went into the system and I changed it to PIO seg 0 and I changed it to 7 bits output with the output port reset being 3F. And then I duplicated that 5 times. And what I did was I changed the address, the base address, so they don't collide with each other, but all of them are connected up to the clock and the reset, and then the LW AXI master, and then all of them are connected to their own external connections. So I just generated the HDL file, and now I'm going to copy the instantiation, and then I will regenerate the project. So now I'm back in the project and I just copied and pasted the instantiation. And so these are the new ports that we need to connect up. So let me just copy those ones. Take those lines. We're going to get rid of this. And let's just delete all that. So we're not going to be using these LEDs anymore. So I'll just probably tie those off. So that's how we'll tie off the LEDs. And so now we need to have ports for the 7-segment displays. And up here you can see the 7-segment display ports. So we'll just take all these hex ones. And so now we should have this connected up. And let's get this compiled and running. So after a few syntax fixes, I zipped up the entire folder and then I copied it over to the window environment. And so now I'm going to continue over in Windows. So now I've unzipped the file or the folder in the Windows environment. Okay, so after some fixes, I finally got it to work. So basically what I had to do was I had to add these lines right here and which lines? These lines right here into the SOPC create header files, and then I was finally able to get it to run. So then in this file, you can see that it has the 7-segment things now. And let me do a quit out of that. So to get that to run, I had to, let me just scroll up. So to get that to run, I had to add to the path this right here. And then I had to edit that document that I just showed you. And then once I did that, I could finally run this and have it generate the HPS file. So let me create a new area. So for the HPS, I'm gonna let me just copy this HPS C to HPSC modified. Do that recursive and force it. Then we'll go to the HPS modified. So we'll remove currently the HPS 0 file. We'll remove the main output file, and we will remove my first HPS FPGA. So let's get rid of all those. And so now we're going to go into the main and we're going to modify this. Alright, so this is the code that I put together real quick. So I got rid of a few of the integers. I added some addresses and deleted the old one for the LEDs. And then I created this array that would hold the 7-segment values from 0 to 9. And then right here, I set the addresses based on their base values over in this file right here, in this header file. So if we do that, you can see, so that's the base address for 7-segment 3. And then I have this simple loop right here that just goes through and sets the 7-segment display to the loop count mod 10, the loop count divided by 10 mod 6, loop count divided by 60 mod 10, loop count divided by 600 mod 6, loop count divided by 3600 mod 10, and loop count divided by 36,000 mod 10. And then when it reaches 86,399 loops, then it resets back to 0. And then otherwise it just increments. And then here it should wait for a second. It doesn't necessarily account for the time that it'll take to do all this, but close enough. And so after that, let me build this real quick. So I will run, okay, let me do an L real quick. So I copied the HPS 0.h file, and this main.c is what I've been modifying. Let me run make. And so there's some error right here. So I need to go fix a little syntax error. And then let me run that again with that syntax fix. So now I will go copy this to the Linux and then program the FPGA with the SOF file, and I'll show you what that's like. Okay, so I've gotten this command set up already, and now I'm going to flash the program, if I can find my mouse pointer. So let me start this real quick. So this should be programmed, and let me just get this running real quick. Oh, let me just hit the enter button. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so some of these digits are obviously not correct, so I'm gonna have to go back in and fix that. So let me show that. Okay, so I just fixed some syntax error with defining how 3 and 9 are displayed. So you can see I copied it back over. I made it again and I copied it back over. And I don't even have to reflash the FPGA, so it's already flashed. But I canceled out on the last command, so let me rerun that again. So just hit up and then hit enter. And you can see it restarts. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it rolls over to 10. And I will show this until it reaches past 1 minute. So this probably takes longer than a minute, like I said before, because it's not really accounting for all the time that it takes to do all that stuff before it waits 1 second. But there, it rolled over to 1 minute, and then it'll run all the way up to 24 hours, and then it'll reset. So there it is. And here I am about an hour later after starting to edit the video a little bit, and it's still running, and you can see it's already passed an hour and 10 minutes.